Very good morning, all my dear students.
Good morning, sir.
Today we will see a new topic, pressure measurement. In the last class, we have seen some numericals based on Pascal's law and hydrostatic law. Anyone from the class who can tell me what is the mathematical expression for your hydrostatic law? Anyone from the class? Mathematical expression for hydrostatic law. Am I audible to everyone?
Yes, sir.
Okay, so then tell me what is the mathematical expression. Based on that expression, we have solved few numericals also in the last class. Anyone from the class? Very simple expression it was. You can turn down your notebooks. Tell me the answer.
P equal to rho into G into Z.
Yes, P equals to rho into Z into Z. So this is the very basic law that will be useful, very useful. Okay, so I'm writing in the chat box, P equals to rho into G into H. Yeah. So all of you in the class, now we have 32 participants. Write in the chat box, P equals to rho into G into H. Then we will start this measurement of pressure, new topic for the today. P equals to rho into G into H. In place of H, you can write Z also. Both are representing the height. Okay, very good. Now we have 37 participants and it is around 10:05. Okay, so let's start. Till now we have seen what is fluid, its properties, Newton's law of viscosity. Then we have seen what is pressure, what are the units of pressure. After that we have seen one derivation for Pascal's law. Then we have also seen the derivation of your hydrostatic law. Based on two laws, we have solved few numericals also. So today we are going to start measurement of pressure. That is also a very important topic for your university examination as well as your competitive examination. So let's start. Pressure in a fluid can be measured by two devices. Okay, what are those two devices? The first one is your manometer. The second one is your mechanical gauges. Now we will see what is this manometer and what is this mechanical gauges. So manometers are defined as the devices used for measuring the pressure at a point in a fluid by balancing the column of fluid by the same or another column of liquid. Okay, so if you will focus on this definition, suppose I would like to give you one practical example. this is my water bottle, okay, and suppose I have filled some water in it up to here at this level. Suppose it is filled with water. By now it is up to here only. Suppose it is filled up to here. Now what I'm going to do, I'm going to make a hole over here and insert a pipe, small tube, glass tube, and it will be like this, horizontal then vertical. So then what will happen, what you will observe, you will observe the water level in this bottle and the water level in this glass tube will become at some level. Okay, so this is the definition and this is the basic principle what we are going to utilize here for your manometers. Okay, so here as you can see the definition, manometers are defined as the devices used for measuring the pressure at a point in a fluid. In that water bottle we are making some hole, so at that point we are measuring the pressure. So measuring the pressure at a point in a fluid by balancing the column of fluid by the same. For this case, the example that I have given, it is for the same liquid, or also we can do it for another liquid. Okay, so when we will see the different type of manometers, we will see what is the difference between this same liquid and another liquid. Because what we can do, suppose here I had made a hole and I had made a glass tube inserted over here. So we will be able to measure the pressure at this point. Okay, all of you remember this point. If we are inserting the manometer here, so the liquid level above this point, the column of liquid above this point, the pressure created due to the liquid level present here, that can be measured using this manometer. Okay, so for this case, same liquid will be there. Suppose in any case, I have filled some other liquid in this glass tube, heavier than the liquid present in this bottle. So in that situation, this another column of liquid is come into the picture. So I hope you are now clear with the definition of manometer. Now let's see what are the different type of manometers. Simple manometer and differential manometer. We will see the example, we will see the figure also, then it will be more clear. Okay, so in simple manometer, you will see piezometer, U-tube manometer and single column manometer. Okay, among these three, most commonly asked questions are from U-tube manometer in your university as well as your competitive examinations also. Okay, so this U-tube manometer is very important topic for your university examination. Theoretical questions can also be asked. What are the different way to measure the pressure at a point in a fluid? Then you have to write down this complete. There are two devices. First is manometer, another one is your mechanical gauges. Okay, so the second type of manometer is differential manometer. Now what is simple manometer, what is differential manometer? I will explain you with the help of a diagram. Okay, but first I would like to tell you about this mechanical gauges. These are the device in which pressure is measured by balancing the fluid column by spring or dead weight. It means there will be some mechanical component. As you have seen, a white gauge is there in your compressor. Okay, whenever you are going to fill air in your motorcycle tire, so there also some white gauge is there. So this is working on this principle. Actually, this fluid column is balanced by some spring or dead weight. So generally this topic, mechanical gauges, is taught in a subject called, a separate subject is there for that, in which you will go for measurements of all the equipments. Okay, in fluid mechanics, this manometer is considered in your syllabus. Okay, so this is in our syllabus, manometers. So we will focus on manometers. So let's start with a simple example or the first type of simple manometer. A simple manometer is one which consists of a glass tube whose one end is connected to a point where pressure is to be measured and other end remains open to the atmosphere. Okay, so here the diagram you can see, I'm marking a tick mark over here. An open vessel is there, you can see, and a glass tube or piezometer tube, here it is written, is inserted at this location. Okay, so it will measure the pressure at this point only. Okay, so you can see the level of liquid in this piezometer tube is represented by this alphabet small h. Okay, so this is your simple manometer or called as piezometer. So here we have open vessel, as I have given you the example of my water bottle also. But suppose there is any pipeline. In that pipeline, suppose some petroleum products are flowing. Maybe in your locality you have seen water pipes are there, municipality water pipes. So in that pipe water is flowing. In petroleum industry or gas industry, some gases may be flowing in that pipe. Okay, so how to measure the pressure of that pipe? So the simplest way, if the pressure is low, okay, we can insert a small tube in that pipeline. Okay, and we will observe that as soon as we are inserting the pipe in the small tube, this piezometer tube in that pipeline, the level of the liquid which is flowing through this pipe is going on this piezometer tube also, and it will be elevated up to certain height. Suppose the height is here written as h. Okay, so if the height of liquid column is known to you, then using your hydrostatic law of pressure, you can easily calculate the pressure at that point. Okay, so the formula is rho into g into h. Okay, that basic formula we will use here also. Now let's see the definition of piezometer. With the this diagram I have explained you. Now let's see the definition. Piezometer is the simplest form of manometer. See, the simplest form of manometer, which can be used for measuring moderate pressures of the liquid. Very important. Only moderate pressure or low pressure. Why not high pressure? Can anyone tell me in the class? Why we will not be able to measure high pressure with this setup?
It will be flow, sir.
If the pressure will be high, then what will happen? Suppose inside this pipe, the water pressure is very high and we are going to insert one piezometer tube, then the water will start going out from this tube. Okay, so one point you can note that this simplest manometer can be used to measure only moderate and low pressure of liquids. Okay, this thing you have to keep in mind. Now, it consists of a glass tube, as I have told you, inserted in the wall of a vessel or a pipe containing liquid whose pressure is to be measured. Okay, the tube extends vertically upward to such a height that liquid can freely rise in it without overflowing. Very important point, this you have to keep in your mind, without overflowing. And that's why we can measure only moderate or low pressure using this piezometer tube. Okay, this is the disadvantages. So you can take down in your notebook, using this piezometer or the simplest manometer, you can measure only moderate pressure or low pressure of liquids. Now, next line. The pressure at any point in the liquid is indicated by height of the liquid in the tube above that point, which can be read on a scale attached to it. Normally what happens, just besides this tube, there will be one scale. Suppose for scale I am using some different color. One scale will be mounted over here on which readings are there. So you can easily measure what is the height h from this scale in centimeter or meter or mm. Okay. Thus, if W is the specific weight of the liquid, then the pressure at a point is given by P equals to W into H. Okay, where W is the specific weight of the liquid. And for a specific weight, we can write rho into G also. Okay. We have seen this in our primary classes. Now, piezometer measure gauge pressure only. Another important point, it measures gauge pressure. In previous class, we have seen gauge pressure, absolute pressure and atmospheric pressure. Okay, so the simple formula is absolute pressure equals to gauge pressure plus atmospheric pressure. So here in piezometer, what we are going to measure? We are going to measure gauge pressure only. Okay, at the surface of the liquid, since the surface of the liquid in the tube is subjected to atmospheric pressure. Here it is open to atmosphere. Okay, so some pressure is acting on this surface of the liquid also. Here open surface of liquid is there na, so that the pressure due to atmosphere is also acting on it. So we are not considering that, because at both the locations we have open surface. Okay, so we are measuring gauge pressure only. A piezometer is not suitable for measuring negative pressure. Third point in your piezometer. The first one is your it can measure only moderate pressure. Second point is your it can measure gauge pressure only. Third point, now what is coming? It cannot be used, it is not suitable for measuring negative pressure. Yes. Now anyone in the class, can you tell me why it will not be used to measure negative pressure?
It will force down, sir.
It will force down. Suppose your answer is somewhat correct. Suppose we have one pipeline. In this pipeline, any gas or liquid is flowing with negative pressure. Okay, negative pressure means, suppose here at this point you have PA, at this point you have pressure PA, outside you have P atmospheric. Let me bring my board, then I will write on this board. Okay. Outside you will be having PATM. Not writing properly. PATM. So for this case, okay, if we have negative pressure, then PA will be less than PATM. Okay, and we all know that any fluid flow from high pressure zone to low pressure zone. So what will happen in that situation? The atmospheric air will start entering into this piezometer tube, and it will go inside and it will mix up with your fluid inside the pipe. So it is not possible to measure negative pressure using this piezometer. Okay, so here we have seen one point, it can measure only moderate pressure. Second point, it will measure the gauge pressure. Third point, it is not suitable to measure the negative pressure. Okay, as in case of air will enter the pipe through the tube. One more point I would like to add here, we will not be able to measure the pressure of gases. If some gas is flowing in this pipe, for liquid it is fine. Suppose if some gas is flowing inside this pipe, then what will happen? Gas will escape out to the atmosphere from this vent or from this tube. Okay, so for gases, this piezometer cannot be used to measure the pressure. Okay, so is that clear to all of you? Is that clear to all of you? Write in the chat box, yes sir. Simple piezometer. So write in the chat box, yes sir. Okay, if you have understand this point, then it will be easier for you to understand your YouTube manometer. And once again I am telling you, YouTube manometer is very important for your university exam. This is the last topic of unit number 1. Okay, so maybe today I will finish unit number 1. If you want one more class, then tomorrow also I will take this topic to solve some numericals. Okay, So
Okay, sir.
what are the 4 points we have discussed here for piezometer? At disadvantages of piezometer, the first is it can measure only moderate pressure. It cannot be used to measure high pressure. Okay. Second disadvantage is it cannot, or it is not suitable for measuring negative pressure. Okay, this is not disadvantage. Gauge pressure is not disadvantage because all manometers will measure only gauge pressure. So the disadvantage is it cannot be used to measure high pressure. It is not suitable to measure negative pressure. It is not suitable to measure pressure of a gas flowing through any pipe. Okay, so these are the 3 disadvantages that you can keep in your mind for your viva examination, for your question in interview, for your university as well as competitive examination. So if you want to note down some important points from this slide, you can draw the diagram and you can write down the 4 points that I have told you right now. Draw the diagram, write down the definition of this simple manometer here. And draw this diagram. And write down the disadvantages of this piezometer, the 3 points that I have told you. And once you complete taking down your notes, type in the chat box completed, sir. I hope you all have written those 4 points. Not suitable for measurement of high pressure. Second point is not suitable for measuring negative pressure. Third point is not suitable for measuring the pressure of gases.
Sir, second third what, sir?
Second point. Second point is your not suitable for measuring. Here it is written. Not suitable for measuring negative pressure. So you have to remember this term, negative pressure. Not suitable for measuring high pressure. It will only measure moderate pressure. And the third point is, it is not suitable for measurement of gases. I hope you all are updating your notes also. At the same time, I would like to tell you all the students that I have uploaded all the video lectures on your Canvas account. If you will open the Canvas, go to the subject fluid mechanics. Okay, then one option you will see page. So you have to click on the page. You will see two pages are created. The first one is your syllabus and the second one is your chapter 1. So all the video lectures of chapter 1 is uploaded there. You can directly play it and update your notes. Whosoever have missed any lecture of fluid mechanics. So I hope you all have noted down this. This previous slide also you note down. Yes. What are the pressure measurement device? Manometer is there, mechanical gauge is there. In manometer you have two types, simple manometer, differential manometer. In simple manometer we have started with piezometer, then we will see U-tube manometer, we will see what is single column manometer, and then differential manometer. So write down the definition of manometer and mechanical gauges. Here we have four types of mechanical gauges: Bourdon tube pressure gauge, diaphragm pressure gauge, bellow pressure gauge, deadweight pressure gauge. You can remember the names. These are not in our syllabus. We have to only focus on manometer. Okay. All of you have completed this? Can I move ahead?
Sir,
Okay. So let's move. Now see what is U-tube manometer. Very important topic. All of you listen carefully, pay attention. Okay, because one numerical from this U-tube manometer is generally asked in many competitive examination. Okay. So whatever the disadvantages that we have seen in our simple manometer, or piezometer also we can say that, that will be overcome with this YouTube manometer. Okay, so for this, if you first see the diagram, try to understand, then we will go to the definition. Okay, so try to understand what is this. This is this circle is representing some pipeline. Okay, the pipeline is coming out to the out of the surface of your screen. Okay, it is perpendicular to the screen, so the cross section is circle we are showing here. So we are connecting this YouTube. Why this is called as YouTube? Because you can see it is U in nature. Okay, so it is U tube manometer. Okay, and this pink color, this magenta color, you can see pink color is filled in it. This is some heavy liquid, heavier than the liquid inside the pipeline. Okay, the pipe inside the pipeline, you can see blue dashed are there representing some liquid is inside it. Suppose the pressure at this P at this point A is PA and outside pressure is P atmosphere. Okay, so for this case, if inside pressure is more than the P atmospheric pressure, then what will happen? This liquid will try to push this pink color liquid or heavier liquid. That pink color liquid is called as manometric liquid. Okay, this is a manometer. In manometer, some liquid is filled, so it is called as manometric liquid or manometric fluid. Normally we use mercury. Normally we use mercury in our manometer. In our laboratory also, you will see in all the apparatus, your YouTube manometer is installed to measure the pressure of a point inside a pipe, to measure the pressure of the fluid flowing through that point. Okay, suppose if here the pressure is no pressure, no liquid inside that, then what will happen? In that situation, the level of this manometric fluid on both the sides, it will be equal. Due to gravity, what will happen? It will be of equal on both the sides. Okay, as soon as suppose you started the motor or you started the pump and the liquid started flowing through this pipe, then what will happen? This liquid will be starting flowing inside that pipe, and the flowing fluid will try to push this manometric fluid, and you will see a difference in height on the left hand side and on the right hand side. So on this side you can see it is going down, and on the right hand side you can see it is going up. Okay, so in solving all the numericals related to this manometer, what we will consider, I am drawing a center line over here. Okay, so this side we will consider as left hand side, and on this side we will consider as right hand side of the manometer. Okay, then we will do equivalence, pressure equivalence on the left hand side and on the right hand side. Okay, now see the definition. Now I hope you have understand the diagram what it's showing. Here you have positive pressure inside the pipe. For the case in the simple manometer or piezo-manometer, we are not able to measure negative pressure. See the second diagram. Here we are going to measure negative pressure also. How? Suppose some fluid is flowing over here. Maybe liquid, maybe gases. Here gases can also be measured. So what will happen if there is negative pressure? This will try to go inside. It will, this inside fluid, you have less pressure or vacuum pressure. So it will try to suck. It will try to suck your manometric fluid. Okay, whenever now I am using this term manometric fluid, then you have to keep in your mind that I am talking about this pink fluid inside your YouTube manometer. Normally, it is heavier than the liquid inside your pipeline. Okay, and most commonly used manometric fluid is mercury, and its specific gravity value is
13.6.
13. Okay, this value you always remember. Okay, generally it is asked in your Viva. Every now and then people used to ask in your Viva what is the specific gravity of mercury. Now this is the case for your positive pressure. This is the case of your negative pressure. Both the cases. Positive pressure can also be measured. Negative pressure can also be measured using this U-tube manometer. Okay, now you can see the definition what is written here. Piezometer cannot be employed where large pressures in the liquid, in lighter liquids are to be measured. Okay, here why it is written lighter liquid? Can anyone elaborate or try to elaborate? Anyone from the class?
Space
Basic.
is narrow, sir. Narrow space.
You have to use that mathematical expression P equals to rho,
which has less density, sir.
yes, rho into G into H. So as you can see here, height H is directly proportional to the pressure P, and this height H is inversely proportional to rho into G. This is your rho. Rho is representing your density and G is your acceleration due to gravity. So for this rho into G, I can use one single term also, that is your specific weight represented by small w. Okay, so for this rho into G, I can also use this term small w. So here you can see from this mathematical expression, as in our previous slide, this height will be directly proportional to the pressure available inside the container or inside the pipe. Okay, so as the height will the pressure will increase, height will also goes on increasing inside your piezometer or your U-tube manometer. Okay, but reverse is the case, since H is inversely proportional to your density of the fluid. If density is more, then what will be its effect on H?
Less.
Less. As the density will increase, the height will be less. Suppose you are some viscous fluid is inside that pipeline. Suppose your mobile is more viscous. Okay, or lubricating gels or lubricating oils are there. They are more viscous. Those liquids are flowing inside that pipe. Okay, that are more density also. Okay, so for those type of liquids, less height will be obtained. Same opposite is the case for your lighter liquid. If the liquid is lighter, then what will happen? For a small increase in your pressure, very high increase in the height of the liquid column you will observe. So in piezometer, it is not suitable for lighter liquids also. Okay, since this will require very long tubes. Okay, suppose you have very light liquid, and as I have told you, for a small increase in pressure, there will be very high increase in the height of the liquid in this column. So for that, what you will need? You need a pipe, this pipe with very long length to measure the pressure of lighter liquids. So piezometers cannot be employed with large pressure with lighter liquids. For lighter liquids, you need longer tubes which cannot be handled conveniently. Okay. Furthermore, gas pressures cannot be measured by piezometer because gas form no free atmospheric surface. So these things I have discussed in previous slide. So these are the limitations that can be overcome using your U-tube manometer. Okay, so a U-tube manometer consists of a glass tube bent in U shape, one end of which is connected to a point at which pressure is to be measured and the other end remains open to the atmosphere. Here you can see it is open to atmosphere. One end is connected to the pipeline and another end is open to the atmosphere. So this is your U-tube manometer. Okay, so note down fast, then we will go to the mathematical part of this U-tube manometer. Write down fast. I'll give you 2 minutes. Draw fast. Draw the diagram, take down this statements, very important statement, and draw both the diagrams. For positive pressure, here I have drawn the positive symbol, and this is for your negative pressure. Negative symbol is drawn over here. Once you completed taking down the notes, type in the chat box, completed, sir. Yes, someone is asking some question. Can you please elaborate this question? 308. I'm not able to get your question.
Sir, hello.
Yes.
Sir, why it is given difference between the pink color and that water droplets?
Due to the pressure difference. Okay, suppose you have no pressure inside this pipeline. Okay, so what will happen? You can do practical experiment also. Suppose one circle I am drawing to represent a pipeline. Okay, in this some manometer is U-tube manometer is connected. So I am trying to draw a U-tube. You can see on the screen. Okay, suppose this is a straight line, a U-tube. Here suppose there is no pressure, and in this tube, okay, let me draw two lines. Okay, now it is looking like a U-tube. Okay, not straight line, but anyhow it is looking like a U-tube. So I'm going to fill some liquid inside it. Let it be green color. I'm going to fill liquid in this U-tube. Okay, so suppose this tube, okay, mercury is filled and it is showing with this green color. Now for this case, we don't have any pressure inside this pipe. Now for the second case, now I'm going to draw one more diagram. That same pipe same U-tube. Now for this case, now suppose some liquid is started flowing in it. Suppose in your house you must have a water pump in your house. So you have switched on the water pump. So water is now flowing through the pipe. So what will happen? Now again I'm going to the green color. when nothing was there, you have not switched on your pump, then this area is filled with mercury. Now, what will happen when you will switch on your pump? The pump water will see some opening on this side. So water will try to go in this direction, and on this it will try to come out from this side. So what it will do, it will try to make or push this liquid, green color liquid. Okay, so what will happen? So it will push it from at some down level. Okay, now the water is up to this level. Okay, and if it is pushing that mercury or this green color from this side, then it will move on this side. So green color on this side will increase. So the label, earlier it was up to here, so this much level is drop on the left hand side, so same level will increase on your right hand side. Okay, so here if you will see, this case is represented here in this diagram number 1, where you have positive pressure. Okay, in neutral case, if there was no pressure inside the pipeline, the manometric liquid on both the sides, left hand side and right hand side, the level of liquid column was equal. Once you have switched on the water pump, water started flowing inside the pipeline. So water will try to push this liquid. Okay, so what will happen? Earlier it was at the same level. Now the water, suppose this side, so you have switched on the water pump, water is flowing inside the pipeline. So water will push it down. So once on this side it will be pushed down, so this side automatically the mercury level will increase, or you will see a level difference. See on this side, the level difference. Now to see the level difference, I'm bringing it here. If you are able to see my video, okay, you can easily visualize what I'm trying to say. So this is the level difference that we have obtained, H1. This is your H1, and on right hand side we have obtained H2. So once we will see the mathematical part, it will be more clear. Like this, if you have any doubt, you can ask me. I will explain it for all the students. I hope you all has noted down this one. Shall I go to the next slide?
Sir, 1 minute, sir.
Okay, okay. So it's already 10:50. So what I am thinking, we will see the mathematical part in the next class, that is tomorrow. So you note it down, then I will show you in your canvas how I have uploaded all the videos by sharing my screen. So you can, in your leisure hour, whenever you are free, you can go through those lectures once again and complete your notes of your own. Don't copy it from your friends. All the video lectures are now available to you. You open it, watch it carefully and complete your own notes. I have seen in the assignment, some of the students are copying the same notes that your friend has created and you are uploading that assignment in the Canvas account. Don't do that. For that only I have uploaded all the video lectures.
Sir, can you give me time, sir, for uploading the?
Yes.
Can you give me the time, sir, for uploading the submission canvas?
Submission date is already over. You are already very late.
Okay. So,
Anyhow, you can submit it, but you will get less marks. Okay, to
okay.
get some positive marks, you can still upload it, but you will get less marks.
Okay, okay.
Okay, everyone completed, noted down this slide?
Yes, sir.
Okay, now I will show you the Canvas account. So this is my Canvas account. When you will open your Canvas account, you are also registered to many of the subjects. So here on your dashboard, multiple subjects will come. You have to click on your fluid mechanics. I don't know for students how many these options are coming. This screen is visible to all of you?
Yes, sir.
Okay. So in the syllabus, when you will click on the syllabus, you will see the syllabus is uploaded. When you will click on this pages, you can see here, pages is here. So I have created 2 pages. The first one is your syllabus mind tree. So if you remember in our first lecture, I have shown you the complete syllabus of fluid mechanics in this mind tree format, where you have seen chapter 1, chapter 2, chapter 3, 4, 5, and 6. So we
Yes, sir.
have in chapter 1, we have completed all those things now. Okay. So this is the mind tree of your syllabus. When you will go to the next page, that is your chapter 1. If you will click on this chapter 1, you will get all video lectures with lecture 1, lecture 2, lecture 3, all the lectures you can see here. You can directly play it over here and you can take down your notes. Okay, so like this, this is 27th July lecture, lecture number 6. So likewise, all the video lectures are now uploaded. Okay, so I hope it will be very useful for all of you. So that's all for today's class. We will meet again in tomorrow's class with the mathematical derivation of your YouTube manometer, and we will see few numericals also. That will be the end of our unit number 1. Okay, so now I'm going to end the meeting.